right, so yeah, go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and I'll go over the correct answers. So for the factoring, this is a remove, replace, reduce. So you're going to start by multiplying that 3 by 4, and then you're going to have x squared minus 11x minus 12. And when you factor, you need to make sure that you put the 4 back with the x in front. And the numbers you're going to want to use are negative 12 and positive 1. The first set will reduce by 4. So we'll have x minus 3. And then we'll have 4x plus 1. And that would be your answer there. For the math knowledge question, it tells us that we have an angle A where the vertex is at the origin, and one ray is the positive x-axis. So one side of our angle is this. The other ray is positioned so that the sine of A is less than 0, so that means it's negative, and the cosine of angle A is positive. Well, we need to figure out which quadrant could B be positioned in. If we know that the sine is negative and the cosine is positive. Well, that's not going to be in the first quadrant because they're both positive. In the second quadrant, the cosine is not positive, but the sine is, so that one doesn't work for either one. In the third quadrant, both sine and cosine are negative, so that doesn't work. The only quadrant that's going to have a sine that's negative and a cosine that is positive is in the fourth quadrant. So your answer is going to be D for that. Okay, so we are looking at lesson 69 today. We're dealing with matrices and determinants. So hopefully after this lesson you'll understand matrices and determinants. A matrix is a rectangular array of numbers or symbols that stand for numbers. So matrix is the singular, matrices is the plural. But it's going to be a rectangular array of numbers or symbols that represent your numbers. The individual entries of a matrix are called the elements of the matrix and are always arranged regularly in rows and columns. So your matrix is always going to have rows and columns. All of the rows have to have the same number of entries, and all of the columns have to have the same number of entries. Now you can have a different number of rows and columns, but every row has to have the same number of entries, and then every column has to have the same number of entries. It is customary, but it's not necessary to use brackets to indicate an array is being considered as a matrix. So usually we use brackets, but you don't have to. But if you have brackets, then that definitely means that you do have a matrix. The dimensions of a matrix are given by naming the number of rows and then the number of columns. So your rows are the ones that go horizontally. Rows go that way, and then columns go vertically. If you think about columns on a house, if you've ever said, oh yeah, or if you've ever heard someone say, oh yeah, that house has columns in front. Well, you've got your house, and then you've got the columns out front, okay? And those go vertically. So the columns always go second, and that is the vertical number. Okay, so let's look here. These are all examples of matrices, and we're going to practice naming them. So this first one, how many rows does it have? It has 3 rows, and it has 1 column. So it's going to be a 3 by 1 matrix. This next one, it has 2 rows and then 3 columns, so it's read as a 2 by 3. This one would be a 1 by 1. This one would be a 4 by 2. This one here would be a 2 by 1, 2, 3, 4, 5, 6. This one would be a 1 by 3. Down here, this one would be a 3 by 3. This one would be a 2 by 4. And then this last one would be a 2 by 2. So hopefully you see how you would actually name them. And so that's how you call them, by the number of rows and then by the number of columns. Now as you see, some of them have the brackets around them and some of them do not. You don't have to have the brackets. It's just normally people put brackets around their matrices. Okay, so let's look. If a matrix has the same number of rows as it has columns, it is called a square matrix. So if the number of rows and columns is the same, then you're going to have a square matrix. Every square matrix is associated with one real number that's called the determinant of the matrix. And we're going to go over in just a minute how to actually find that determinant. But you can only find a determinant if you have a square matrix. So if you have a rectangular matrix, then you cannot find the determinant. If a matrix is not square, it does not have a determinant. So if it asks you to find a determinant for a rectangular matrix, you can't do it. The determinant of a matrix is customarily designated by enclosing the matrix within vertical lines. So whenever we go to find the determinant, we're usually going to put vertical lines with our elements on the inside. So the way that you find your determinant, you're going to do A times D, you're going to do C times B, and then you're going to do AD minus CB. So you're going to multiply AD and then subtract whatever you multiply CB to B. Okay? The book has this cute little mnemonic or little graphic to help you as a mnemonic. In the book, it says, as a memory device, we will superimpose the problem on a map of the United States and associate the minus sign with the cold waters of the North Atlantic and associate the plus sign with the sunshine of the islands of the Caribbean. So that's what they tell you to help you remember which one's positive and which one's minus. I always just start at the top left, AD, and then go bottom left, BC, and subtract the two. But whatever you want to do to remember that, if you like remembering the cold waters of the North Atlantic and the sunshine of the islands of the Caribbean, you can do that as well. So we want to evaluate this. It has the vertical lines around it, so that means that we're looking for the determinant. So the way we're going to do this, with the negative 4 times 7, that's negative 28, minus 2 times negative 3, which is negative 6. And so negative 28 plus 6 would be negative 22. And that would be your determinant for that matrix. Let's try another one. We want to evaluate it. So we're going to do negative 7 times negative 4, which is 28, minus 3 times 5, which is 15. So 28 minus 15 is going to give you 13, and that would be your answer. So as long as you remember the order that you have to multiply and subtract, you shouldn't have too much trouble with these. Let's look at another one. They set it up a little bit differently. They tell us to find x. Well, we have the matrix, and they're wanting us to find the determinant, but then they say it equals 18. So what that actually means is they did the determinant, and they figured out that it was 18. So we need to figure out what x plus 4 times 4 is. Well, that's going to be 4x plus 16. And then when we subtract 6, we end up getting for our answer 18. And so now we basically just need to solve for x. So we have 4x plus 10 equals 18. So 4x would equal 8, which means that x would equal 2. And so that would be the answer there. Okay, so they told us what the determinant was, and so you just had to set it up and set it equal to 18 and solve for your variable. Looking at one more, it's set up the same way. We want to find x, and they tell us that the determinant equals negative 5. So we're going to do x plus 4 times x plus 2. So that's going to be x squared plus 6x plus 8. And then you're going to have minus 3 times 5, which is 15. And it all equals negative 5. Now on this one, we have an x squared and an x and a number. So we're probably going to want to try and factor it. So I'm going to set it equal to 0. I'm going to have x squared plus 6x. And then I'm going to have minus 2 equals 0. Now unfortunately, that will not factor. So instead, we can do the quadratic formula. So our x value is going to be negative b plus or minus the square root of b squared minus 4ac, and then all over 2a. And so we're going to simplify this. So I'm going to have negative 6 plus or minus 36 plus 8 over 2. So negative 6 plus or minus square root of 44 over 2. The square root of 44 will become 2 square roots of 11. And so all of these will divide by 2. Negative 3 plus or minus the square root of 11. And so both of those would be your x value. So you would put both of those for your answer. Okay, so that's basically the basis for dealing with matrices and determinants. They start us off with 2x2s. We will eventually go to 3x3s. And the same concept can be extended to 4x4, 5x5, etc. But we won't look at anything past the 3x3 this year. Okay, so your homework is 1 through 30. Make sure to do that tonight so that we can go over any questions that you have tomorrow.